Ayo. What happened? Serves you right. I put it there. Yeah. Okay. Okay, Ethan, can you open your AirDrop? Why talking very slowly? AirDrop. Where's your notes? I don't need. I don't surprise. You keep this. Maybe it's free. Someone give it to you. Keep it for a minute. Yeah. You sweating? You're stingless. You stink. Okay. Can I start? Okay, good morning, class. Okay, morning, class. If sweat cell is even more stink, so I have no choice. Okay, so sorry. Next time I change the phone. Huh? Pray for him. He already cannot take it. I saw her like the ice. Huh? Yeah, Cologne. Yeah, expensive one. Okay, come. Okay, let's start. Okay, where did you stop the last round? We stopped at around topic 6, part 5. Okay, topic 6, part 5. Okay, so this week we will be going through assignment tomorrow. We have not gone through assignment yet. Have you all done? Yeah. So if you cannot do, at least try to do more than half. I believe you're okay. So then on Wednesday, we will do practice set 1. Is that okay? Is it too much to ask for practice set 2 on Thursday? No. So can. Alanis can. Jaden Lloyd can. Wei Xiang can. They say don't have math. Yeah, that's right. Oh, sharp. So Tuesday. So you see, this was last week. But last week was just sad. Tuesday there were only 16 people in class. Today is the 5th of May. We will do topic 5 assignment. Okay. On Wednesday, 6th of May, we will do topic 6 PS1. Have you all done PS2? Anyone haven't do? What have you done? Assignment done, PS1 done, PS2 off. PS1 haven't do. They do PS2? By this 2 by Wednesday. Okay? Can now? Can? Lloyd can? Okay, Isabel can? Isaac can? Chloe can? Ethan To can? Ethan Yo can? Joshua can? Can. Okay, so I start. So now, part 5 is on Maxima and Minima. Now, Maxima Minima is the next week's topic, week 8. Week 8, we are going to come out the real life application task, group work. So, it will be on Maxima Minima. Okay, so as the word Maxima Minima suggests is maximum and minimum. Okay, basically, they are used in everyday situation. Okay, so have I thought about the real life problem? The square one. Have you all heard the video here? Okay, so let's say, okay, usually it's a contextual question. Okay, and it comes out every year with that. So let's say, for example, Mitra, one day she becomes very rich. She wants to retire. Okay, she wants to retire. She wants to go to Mitra. What's the country you like to go to? New Zealand. Yes, Mitra wants to go to New Zealand. Okay, so Mitra wants to go to New Zealand. Let's say she wants to have a farm. So in New Zealand or in Australia, for example, I'm the government. I say, Mitra, okay, I give you 100 meters of fence. You can take this land, build whatever land you want. Okay, so what will Mitra want to do? Let's say she wants to open a farm. Let's say an orchid. I want to plant my favorite apple trees. Right now, I want to be Isaac Newton. Right. Then usually, if you are going to take 100 meter of fence, what's your priority? That the fencing must? What must the fence do? You want to plant more tree or less tree? Yes. So what you want is you want your trees to encompass, cover as much area as possible. Okay? Mitra gets 100 meter of fencing. 100 meter of fencing. So far, okay? Can. So now after that, then Mitra will be thinking, okay, so let's say I want to maximize area. What do? In mathematics, when there are no variables, I create my own. So can I say the area is length times breadth, which is x times y? And I want to maximize area. Correct? That's what I call maxima. In this case, it's maxima. Maximize area, maxima. Okay, all? So Zarissa will go over. Zarissa being very good in math, go to Mitra. Mitra can't help you. Okay, so basically, that means Zarissa will draw this graph. You say, okay, let's say I got this area. There's this x. Okay, so Zarissa will show Mitra. Mitra, come. You want to make money, there's this particular value of x that will give you the maximum area. Okay? Hey, Calvin, I cannot see your face behind the MacBook. Put down a MacBook, everybody. Okay, put down your iPad, everybody. So, how do I find this point? Mitra, you see your understanding in mathematics. How do you find this point? Look at this graph. Which x can give you the maximum? How do I find this point? What's so special about this point? It's a midpoint. It's more than just a midpoint. It's a maximum point, right? It's a maximum point. General Lloyd, this kind of maximum point, right? From your previous knowledge, what's the gradient like? 0. That means, can I say that dA dx is equal to 0? Right or not? So, if I want to maximize area, I need dA dx equal to 0, right? But first, what do I need? I need A in terms of x, correct? Do I have A in terms of x at the moment, Ophelia? At the moment, do I have A in terms of x? What is A? In this case, the function for A is xy. Is it in terms of x only? No, right? No. Okay, so then what do I do? Okay, so now I go to Junkai. Junkai, what do I do? Junkai will say that, okay, hey, Mr. Tan, you know just now, right? Your 2x plus 2y is actually equals to 100. Because the government only gives you 100 meters. Right or not? So it's equals to y, can I say y is 50 minus x? Correct? Therefore, if I sub it in, can I say that since area is xy, can I say area is the same as x times 50 minus x, which is 50x minus x squared? Is it okay? Can? Then how do I find dA dx? Very good. I'm glad someone's paying attention. Yeah, of course, you're all looking at your iPad. I feel so sad, like the neglected grandparent. Okay, so what's dA dx equals to? Joshua, what's dA dx equals to? Chloe? Joshua? Correct. If I equate this to 0, Ethan Yo, what will x be? 25, correct? So what does that tell you? Okay, then what about second derivative? Is Dorcas, what's second derivative in this case? -2. If your second derivative is negative, is your point a maximum or minimum? It's usually opposite maximum. This tells you that x equals to 25 gives the maximum area. Is it okay? Can I? Which one? I mean the graph will show you that it's a maximum point, but usually not all functions we can use graph. In this case, it's a nice quadratic because I choose a very humble and nice quadratic graph. Hey, quieten down. You are disturbing my class. Okay. Hey, you all keep at you. Go outside, go outside. Okay. Look here, don't look at that. Yeah. So what does it say? Okay, x equals to 25 means what? This is 25, right? Mitra, what is this? 25, right? So what does it tell you? If I give you a fixed parameter, the maximum area that I can actually cover is actually a square. That's why you see the farming, a lot of the areas are squares. Clear so far? A lot of the areas are squares. Clear so far? Yeah. So that's why, because the square, and in fact, the triangle that can cover the most area will be what kind of triangle? Isosceles. Equilateral, because all sides are equal. Okay? That's the idea. Can I? Okay. So yeah. So now let's start on this question. Okay. Let's start on question 5.1, 5.2. So what do you want to do? You notice the variable is x. X, for example, which is the side of the field. Correct? What's the quantity to be maximized? Area, where area is x times y, which is the same as 850 minus x. Then after that, I differentiate dA dx. Correct? Then after that, I solve dA dx equals to 0. I got x equals to 25. Then you notice I check. Second derivative is equals to -2. Clear so far? Okay? So that's what I'm doing over here. Okay, y'all? Differentiate. Equate to 0. Equate to 0. Why are you touching the wall? Huh? Because I whack the wall. Okay, can I? So with that, can you now look at question 1? Okay, so I think you'll read yourself. 5.1. Okay, 5.1. Let's take a look. Yeah, to be very, very not difficult, not difficult. Have you all done 5.1, 5.2, 5.3? Let's look at these 3 questions. After you done, then who's finished with all 3 questions already? Have you tried the challenging? It's very challenging. So tell you first, it's very challenging. Huh? Who's had a challenging question? Okay. It's too challenging. Yes. Cannot do, never mind. Cannot do, never mind. Cannot do. I can do practice set. So the first one, what is the variable? Okay, let's say the variable can be x now. I draw a triangle out. Okay, in case you are stuck, try to draw a triangle out. Draw a triangle out. The area that you want to maximize is triangle. Okay. What do you want?
Ask a question.
Question take. Go and buy yourself lah. X is not equals to 10. So but x and yz is x, right? The yz and xy have a fixed total length of 10. So what EV you can do? You draw a triangle out. Try to draw a triangle. XYZ has a right angle at Z. Now this is X. Let's call this X. This is Y lah. Now YZ is X, right? So I'm going to call this X. So if this is X, EV, the total length is 10. What would this side be? Total length is 10. Okay. So this is, no, this one not 10. So 读直到直细的读。Yes, correct. Very good. Then XZ, wait. X, YZ is X. The question got say, read the question. Change it to X. Then the other one will be 10 minus X. 10 minus X. Because, yes, because both add up to 10, right now. what's the area? What's it? That, no, XZ. Okay. YZ. Okay, these two add up to 10. YZ is already X. So XZ is 10 minus X. Yeah, correct. XZ is 10 minus X. Correct. I show you for the diagram, okay? So you look, oh, it is correct. But you don't need to write so much. 直接写下去，直接写啊，不需要，我不需要你 express，就写下去啊，直接写，直接写。Yes. No. Let me see. Yes, correct. That makes sense. Whatever you say is correct. But if you can, you go right one step. Okay. Whatever you show me is on the screen. So these two add up to 10 based on the question. Okay, how? So distracting. Stop looking. So after that, the area, have you check secondary? Check secondary. So you differentiate one more time. Okay? Can I? Wait, 5.1 to check already? Secondary part. You check secondary? Okay, very good. Okay. Okay. Question 2, check the secondary. Oh, so you differentiate one time. And so here, what's your DC dx? DC dx equals to 12x minus 12000 x to the power of minus 2. Okay? Then you differentiate one more time. D2c dx squared. No. Just now got give you time to go, now don't want to go. Huh? Okay, go fast one. Next time before I come in, 5 minutes, you don't go toilet. Okay, so far, very empty your bladder. Wash your face. Okay, copy. What are you doing? You are not doing maths.
There's nothing. That was not what I was laughing at. That was not what I was laughing at either.
What are you laughing at? What are you laughing? Ah. What is this?
This is my passport photo for the
We're looking at it just now.
dragon boat is my passport photo because the form requires it.
Yeah, then you shouldn't do it now.
Huh, that was not what I was laughing at.
What are you laughing at?
That was not laughing at.
Believe you. Yeah. 这很难呢，要问我不会。Okay, for Q, you need to find the equation of RQ first. Then you start with y equals to 0.
I get like sine inverse positive sine.
No lah, not sine inverse lah. Okay, so you divide by sine. Divide by sine, not sine inverse. It's 1 over sine. Sine inverse and 1 over sine. One is the inverse function, one is the reciprocal. Okay, so sine x to the power of -1. This is 1 over sine x. It's the same. It's not the same as sine inverse. Sine inverse is like that. Sine x equals to half. X is sine inverse half. This one is sine inverse. That's the inverse function.
I'm supposed to find x.
No, you sub okay, to find q, right? You sub y to be 0. So now you have this, right? What is that p? Cosine p plus sine p. Huh? Then what about this x? Why you never sub? This is sine. Oh, okay. Here, inverse. There's another way. Check. Okay. So have you found the equation of the tangent? I check the equation of tangent first. The equation of tangent, you see, check. Is it correct? See this one? This one? 有吗？对吗？ Not the same. Not the same. Yeah, because from my recollection, we don't have to use a inverse. That's not what you found. Okay, 1 second, Zoe. Okay, so let's say I go to this. Okay, first here, right, they're asking for M, which is the midpoint of QR in terms of P. Okay? Yeah, so that means we see, we want to find M, right? Here, I need to find R and Q. If I want to find R and Q, I need the equation of the tangent. So what will bring to my attention is I need the equation of tangent. Okay. So what's the equation of tangent? So first, to find equation of tangent, I need to differentiate. You understand? So it's like everything I do, I think 10 steps behind, 10 steps forward. So what's the gradient? Now, remember y is equals to cosine p, right? Cosine x, right? dy dx is negative sine x. Okay, now if I sub in x equals to p, your gradient is equals to negative sine p. Okay? Negative sine p, then that's okay. So this is like my y gradient, right? Right now. Then this is like my x1, y1, right now. Correct? Then, you see, y minus y1 minus y1 equals to gradient x minus x1, x minus x1. Is that okay for you? I use different colors so you see. Y equals to negative x sine p plus p of sine p plus cosine p. Is it okay? Can I? So then it's not sine x. So you see mine's a bit different. So you will find that when let's say now I go to the step where I'm going to find Q, right? So this is the equation of the tangent. So let's say I'm going to find Q. To find Q, right, I will substitute y to be 0. So Sitong, you see, I sub y to be 0. If I sub this as 0, you will see that I have 0 equals to negative x sine p plus p sine p plus cosine p. Okay, now just make sine p the x the subject. Okay, I bring this to the right left. I divide by sine p. Okay, so what am I showing you? This is p sine p plus cosine p over sine p. Look at this. This is so beautiful, right? I can see like the chopping to 2. There's basically a p. There's a p here plus p cotangent. No, don't have p. Sorry. Wow, so many p. I am so pissed off. Okay, so yeah, can I? So this is the coordinate of Q, but you have to be patient. It's definitely super uber disgusting. Yeah, give me a try. Give me a try. You have nothing to lose, right? You're already ahead of the rest. Okay? And yeah. Okay, so C is basically the cost. The cost. Now, because what we are doing is we are trying to minimize cost. Okay, so some people will say, okay, like I think I have to go another class, the student will just say, sure, why not just find the dimension, minimize the dimension, correct or not? Yeah, because sounds legit, right? But the thing is, the costs they are different costs. The sides have a certain value. The sides would be more, the top and bottom more expensive. Maybe make it better. The top and bottom cost $3. The bottom, the sides cost $1.50. Okay, so I don't know how to put it clearly, but because the cost of the sides and the top are different, you cannot put you cannot just differentiate the dimension. You need to find a legit function for the cost, because over here we are minimizing cost. So that means Zoe, what are you visualizing, right? Zoe will visualize that, hey, that means Mr. Tan say, right, I want to minimize cost, right? There's a cost here, some function with the y-axis. There's an x that will minimize the cost. Okay, so I think you can see what I'm trying to do here. This is the side, top and bottom. The top and bottom, I multiply by 3. which is the cos. The sides I have, each side length times breadth is 2000 over x squared times x multiplied by 4 sides. Multiplied by $1.50. You're right. Actually, I don't know. But I'm trying to, because this is not quadratic. You know what I mean? But because I want to show you that we are trying to minimize something. So in my mind, I was trying to show you a graph with a minimum point. Yeah. It's something that I visualize in my head. Because once I show you this, right, it is very clear to you why I'm doing dc over dx equals 0. Correct? Right now. Because if you can visualize that you are doing something like this, right, you can visualize why you do dc dx equals to 0. You can visualize why you do d2c dx squared more than 0. Okay, huh? And a picture paints 1,000 words and gives you 1,000 understanding. It's for challenging question. So now you are back at the. Have you found what have you found? Have you found R and Q yet? I just checked. Have you found the equation of the tangent? You have found the equation of is your equation of tangent looking like this? Hey, is your equation of tangent looking like this? This is the equation of my tangent. Okay, so back to this question, challenging question over here, which I'm going through. Okay. So here I'm finding Q1, right? Okay, have you found R? To find R, you will sub X to be 0. Clear? Yeah, so you sub X as 0, Y as 0. That's what I'm doing. So you see, okay, what's the fundamentals? What's the fundamentals of finding X and Y intercept? To find the X intercept, you sub Y to be 0. To find the Y intercept, you sub X to be 0. So what's the equation? The equation is here. Okay? Because this equation, you sub Y to be 0. I thought this is my X. So, okay, you see, bring this to the left. Divide by sine P on both sides. Is it okay? You know what I mean? Do you feel P what? So from here, then yeah. So after that same equation, y equals to negative x sine p plus e sine p plus plus cosine p. So what I'm doing is I shift by sub y to be 0, right? Y equals to 0. I have x sine p plus equals to p sine p plus cosine p. So to try to say divide by sine p. It says p sine p plus cos p over sine p. Algebraic manipulation is half the battle. Ophelia. Okay. Are you a PSL? PSL, right? PSL. Okay, so here, those one. You take this, right? You change. Yeah, that's why I make it potential. Okay, so cancel is basically P plus potential P. So that means your Q is P plus potential P, comma 0. Yes. After that, do you know how to find R? Yes. No. Why you never go just now? Okay. Okay, so R is what's the coordinate of R? I'm not sure. P sine P plus. Yeah, P sine P. Okay, P sine P plus cosine P. So R will be 0, then P sine P plus cosine P. Okay. After that, Javier and Timothy and Junha, I hope you all have not given up on the challenge question. Knowing your character, I know you all will find. I'm very sure that if I go over, I'll see all 20 question. And definitely not the practice set. So what's the midpoint of QR? Remember, midpoint is basically what? X1, XY1, X2, Y2, right? So midpoint of QR is just X1 plus X2 is 0 divided by 2. Y1 plus Y2 divided by 2. It's very disgusting, but I hope you solve. Okay? Does it work? I wonder if it ever works like this. Never mind. Okay, okay, so now I go to part 2. Anyone have part 2? Yes. Why? Hey, why all my lesson want to go toilet? I'm going to lock the boys' toilet. No more going to toilet. Mitra, what are you doing? That is not bad. Okay, yes. Toilet. Okay, go. No more going toilet, who else want to go toilet? I already give you 5 minutes to go, still don't. Okay, so the normal to the curve at P cuts the x-axis. Sorry, part 2. Okay, so how fast is the gradient changing? They are looking at the gradient. OM. Where's OM? Who's working on the strategy question? Okay, let's check. 1, 2, 3. Very good. How's part 1? Part 1 done? So part 1 done. Part 2, yeah. Find the gradient first. Okay, so you have, okay, so now let's just, you can call this like a d gradient dt, right? Okay. Hi, who's there? Dragging the chair. You don't drag the chair. Hey, hello. Okay, was it you? Can you say sorry? You say sorry? I never hear. Don't drag the chair. Okay, so part 2, what are they asking for? Let's say if gradient is G, right? Not repetition. Then what do they want? They want to find the gradient, right? Alright, or let's call it M. Let's say call it M. Okay, since gradient is always M, right? So they want to find like the gradient dt, right? What is the gradient dt? What are you given? What am I given, guys? I'm given dp dx dt, right? Dx dt is negative 0.48 unit per second. What do I need? What is the dp dx dn dx you mean? Yeah, dn dx, right? So if I need dn dx, I will need gradient in terms of x, right? Right or not? What is the gradient of line OM? What's the gradient of line OM? Can anyone tell me? So very simple. Guys, just look, right? Okay, look at these 2 points. Look at these 2 points, right? This is OM. This is the OM. Okay, let's say OM. This is OM, right? This is the line. Okay. What's the gradient of OM? What is the gradient? What's the gradient of OM? It's basically y1 minus y2 again. y1 is y minus y2 over x1 minus x2. What do you see here? What's the gradient? No. Am I wrong? No, I say wrong. What's the gradient? What's the gradient? Yeah, this one. Sorry, this one. Okay, huh? Yeah. Let me just check. Wrong. I circled to the wrong thing. It's so very misleading. Let's say M is somewhere here, for example. M is somewhere here. So OM is over here. Okay? E plus potential over whoever who said this question. No, don't worry about it. Okay. So this is basically y1 minus y2. y1 minus y2 over x1 minus x2. Okay, so you can see how the 0 can cancel off, the 2 can cancel off. So you just say this. Okay, so then E of sine E plus cosine. What can you see my writing? Then I still can see. You can see. Is it clear to you? So what I'm trying to do is this is going to be fun. I'm going to multiply. This is the same as sine p. If I take out sine p, right? This is E plus potential E plus potential. This is the step that I think a lot of you all might not be able to make it on your own. So that's why I'm sure. Toilet. Yes. Why do I find D1 dx? Why don't I find D1 dx? Because QR is come from a straight line. Yeah, so I did find D1 dx. So I found D1 dx earlier. D1 dx came earlier. I found D1 dx. This is part 1. I connected here. Yeah, I continue for the mostly I continue here. Now remember, we are finding M. Where does M come from? M come from the midpoint of the 2 points, right? Where are the 2 points from? They are from the tangent. Tangent of the line. So in order to do tangent, I have to do D1 dx. Yes. I'm working backwards. So now this one. Guys, this is quite a crucial step. I think quite a lot of you might not be able to get this far. It's just sine. The gradient of OM is just sine. Okay? So what is let's say I call dx. Dx is like sine x. Okay? It's the same as sine. Sine. Okay? It's like sine p. dx x will be like dx for example will be like cosine. Okay, from here to here. If I were to just write this, let me just change this to p, right? Instead of x, I just change it to I can write it something like this. Then it's easier. Everything in terms of p. What are you looking at? I'm sure it's bad. Why are they all looking at your computer and laughing? Close your laptop. Out of all the 10 people I know in this school who use the MacBook, 9 of them is always up to no good. First is Tambui High, second is Natarajan Mitra, third is Short Tam. Okay. Fourth is okay, because I'm looking at because I realize my gradients in terms of this, right? This is actually the x coordinate. So if I differentiate M with respect to T, cosine. So let's say this is M. This is M. So now after that, when pi can p over 3, when p is pi over 3, dm dt is the same as dm over dt. times E over D, which is the same as cosine of pi over 3 times negative 0.48. Okay, it's very hard, guys. This is very hard. So negative 0.24. Okay, guys. This is part 1, part 2. Part 1, part 2. Challenging question. If I have you, I have you. If you're listening from the start, thanks for tuning in. Okay, but if you have not, just give me a second. Let me go back to the earlier questions so I can help the other students, and then I will continue. Okay? Is 5.3 all right with everyone? Okay, those who are at 5.2. Those who are at 5.2. Okay, can I verify you have got the answer 10 by 10 by 20? 10 by 10 by 20. And if you have 10 by 10 by 20, can I verify again that you have done the first or second derivative test? Okay. Now, just remember, if you only have one stationary value, and the question will tell you maximum, do you need to do the test? Derivative test? Let's say I tell Joshua, find the maximum point. He already found one stationary value. But he still need to do second derivative test. Oh. Yes, you still need to do. Okay, you can see here, even though I found x, right? You still must check. You still must check all the time. Can? If you are in doubt, always do. Clear? Clear? Yes, one. Larissa, okay? Alan is okay? Can, you don't do yourself. Wow. This is very good. Everybody in the class is awake. It's the best $1 investment I ever got. Okay, so, yes. Yes? Oh, yes. What, bro? Hello, I'm 20 years older than you, Call me bro. Okay, So please remember, if you only have one stationary point, make sure that you also do first or second derivative test. Clear? Second derivative test inconclusive, make sure you do first. Can Okay. Is 5.3 okay? But come again? Yeah, so now I go to 5.3. Is everyone okay at 5.3? Seems like everyone is doing well. Wow, if that's fantastic, that means you all have navigated similar triangles very well. Can I just show you what's the answer? Just simple. You can see that for question 5.3, it is so easy to differentiate a second time, right? And when it is such a scenario, you probably don't need to do first derivative. Okay, that's the reason why I do second derivative. Second derivative doesn't always guarantee you the outcome, but it is convenient at times. It's just like the 7-Eleven that is downstairs your house. Okay, but if your second derivative is 0, make sure that you sub. Okay, you check somewhere your first. First derivative, make sure you have a 2/4 table. Clear? And sub in the value, legit to check. 2/4. X value, then minus 0.1, x plus 0.1. Then find 3 value. Okay? Can. So now I go to okay, I'll just wait a while. Wait until some of y'all finish first. Now, challenging question, part 1 and part 2 are on the board. Okay. Please be an expert in understanding and replicating. Don't be an expert in copying. Yeah. Come again. Gradient of a line OM. What is M, right? M is for the first part. This is M. This is M. This is M. Okay, so it's very disgusting, but P's are parameters. When P changes, changes at all. Okay, can I? Now, Write out. Do a paper. So now I slowly go through 5.3. What you're gonna do is probably you can consider the triangle in blue and the triangle in pink. If you look at the triangle in blue, this is y over 5. The triangle in blue here, this is 12 minus x over 12. That's why I can say similar triangles. Okay? Now remember, the trick is always to use similar triangles, Pythagoras, trigo to help you to get the equation in terms of one variable. Okay, if your equation in terms of two variables, make sure you change. After your surface area is in terms of one variable, now you differentiate. You equate to 0. Find the stationary point. Okay, so far? Can I? After that, let me go back again to the challenging question and explain part 1 more time. Okay, since I found out most of you are okay, let's go to part 2. Part 2, they are telling me that the x coordinate is decreasing at the rate of 0.48. Now, what I'm doing is I'm going to make a judgment call. I'm going to do it in terms of p and not x because I am looking at all the values. Now, don't forget that OM is this point. This is OM, right? So OM is basically a point here, somewhere here. It disappeared. So OM was a point that I found. This is not OM, guys. It's not OM. Okay, so there's R and there's Q. OM could be somewhere over here. Like this is the line of OM. This is the line of OM. This coordinate is 0, 0. And this point over here, OM, somewhere over the rainbow. There's a song like that, right? What song is here? Okay, so this is OM. What's the gradient of this line? You can see I can take y1. I'm sorry, x1. Sorry. x1, x2, y1, y2. Okay, make sure you pay attention and stop looking outside. So from here, I find the gradient of OM. y1 minus y2, x1 minus x2. I got it in terms of f. Now, one fun fact, I think it's very hard to get to this fact. Essentially, your gradient is sin p. Sin p. Okay, there's a translation here, which I think most people won't be able to find. It's quite disgusting. Okay, so I hope you pay attention and you try to focus on your work. Once I got the gradient, df dp is cosine p. Df dp is cosine p. P is power over 3, I sum it. Connected rate of 3. Okay, so that is part 3. df dt is the change of gradient with respect to time, which is what they are finding here. So you see now how fast is time, right? Gradient is m, right? And the question wants df dt from you. Okay. Do we have any question?
The same thing as second
in a way, yes. That's a very good observation. Yes. Because sometimes, for example, right, if your function is a quadratic function, if you differentiate one time linear, right, or one, you differentiate another one, it's constant. But anyway, if it's a constant, you don't need to worry about whether there's variable to sub. As long as it's positive, it's giving you the result that you want, take it. Right? As long as it's giving you negative, take it. Yes. Even though you don't get to sub, it's fine. Okay. Like if you saw the question that 5.1, right? So you saw 5.1, right? The second derivative test, I got -1. That's okay, right? Even though it's a constant, it still gives me the result that I want. What I want? I want negative. You show me negative, right? Yes, I'm correct. It's a maximum. Okay? Can I? Can I? Stop talking. Okay, so now I go to 5 challenging question again. I'm just jumping around. I'm going to go to the part 3. Now, show that the normal to the curve is given as follows. This is the normal to the curve. Okay. Now, the normal to the curve at P is the x-axis at point S. So let's see. You can see that there's a normal here. This is the point S, right? So of course, I want to find PQS, right? I know that Q is what is point Q? Q is thank you, my love. P plus cotangent P, comma 0, right? So I want to find P, I want to find Q, I want to find S. Where is my S? My S is basically, where will the S come from? To find the S, what do I need? To find point S, I will need equation of normal. Perfect. I will need equation. How do I find equation of normal? What do I need to do? Change the gradient. Very good. So I change the gradient. So remember that equation of normal is the same as sorry. Let me stand properly. Okay, so it's the same as I'm quite a good shooter nowadays. Y minus y1 equals to gradient x minus x1. Okay? So what is y minus y minus? Who was my y1? Yes, very good. Well done, Joshua. Cosine P equals to negative 1 over x minus x1. What was the gradient? The gradient was sine P, huh? Okay. Negative sign. Oh, don't have negative.
Oh yeah,
Because it was a negative, it's a negative degree. Okay. So basically, y is equals to cosine P plus 1 over sine P x minus P. So that's the equation of the normal. Okay? Can? Okay, so after that, I substitute. Remember, Jaden Lloyd, x-axis means what? How do I find S? How do I find point S? If I want to find the x-axis. How do I find the point S? I want to find the x-axis. In general, we want to find the x-intercept. How do I do? Y is 0. Very good. Okay, so y is okay. Y is 0. So I sub y to be 0. I sub y to be 0. Oh, so 0 equals to cosine P 1 over sine P x minus P. Slowly simplify, expand. X is equal to P minus cos P. Okay, so what does that tell you? Point S will be P minus cosine P sine P, comma 0. Right? Can? Look at this. Beautiful. With this information, guys, where am I going to go? I'm going to go back to the diagram. Hey, time's up already. Oh, the question is so long, I can never explain. Half an hour, 1 hour. Oh my days. Okay, I'll record lesson for this. I'll record for you. Okay. So go and read on your own. We will try appendix, go and read on your own. Okay? Tomorrow, something fine assignment. Yeah. Okay. Thank you, class.